In this video, we're going to be talking about how to determine if two triangles are congruent or the exact same. We're going to start off by only introducing one type of congruency. It's called angle side angle, or the acronym ASA. That must mean that if two triangles are congruent, they have two corresponding angles that are the same, and a side that's in between those two angles is the same. Let's see what that looks like. We'll do a little drawing here. You can listen to me describe what I did to draw here, or if you have a protractor or ruler, you can draw it at home. We're given this triangle. First of all, get rid of that 4 inches. It's not really 4 inches. It's just a little copy-paste image. Let's actually measure this bottom length. In centimeters, it turns out to be about 6 centimeters, so we'll just call it 6 centimeters. We were given the angle on the left to be 60 degrees and the angle on the right to be 40. So because we're doing angle side angle, I'm only going to use those 3 pieces to create a triangle, and we'll see how it magically creates the exact same triangle only with those 3 pieces. So first of all, what I did is I drew a base length of 6 centimeters. I then took my protractor and I put it on the left end point over here and I measured 60 degrees. I didn't care what the length of this segment was. It's not going to matter. I then went to the right side on that endpoint and used my protractor to measure 40 degrees. And again, I didn't care what this length is. Notice that even though I drew them to be longer than they really were, they intersected to be the exact same lengths they needed to be and match that first triangle. So as it turned out, I only needed one length and the 2 angles that surround it to create a triangle that was the exact same. And magically, or mathematically, however you think about it, this length turned out to be the exact same length as this, even though I didn't measure it. And this length on the right side turned out to be the exact same length, even though I didn't measure it. And this angle up top turned out to be the exact same measurement, even though I didn't measure it. So I only needed those 3 pieces together, and all of the other corresponding pieces came together to be the exact same measures. So can we identify if 2 triangles have that type of congruence? Do they have angle side angle? Well, in this diagram, we were given angle B and angle C to be congruent. We were given those markings. We were also given these markings for segments, saying that these 2 sides were the same. So in order to get angle side angle, I must need the angle that comes next. So we must have to determine that these angles are the same. Without any other given information other than the fact that this was a right angle on the right side, well, that must mean that these 2 sides are perpendicular, and of course that would mean that the other side is also 90 degrees. It's impossible for these 2 angles to be anything other than 90 degrees if these lines are perpendicular. So we got angle, 2 angle pairs there. We got 2 side pairs and 2 more angle pairs with the side in between the 2 angles. That matches with our angle side angle congruency. So we can therefore complete the congruent statement here, saying that the 2 triangles are the same, just making sure that corresponding parts line up in order. So if I start by naming B on this triangle, B corresponds with C on the other triangle, so I have to start with C. And then D corresponds with itself and A corresponds with itself. All right, one more time. Let's see if we can look at 2 triangles and determine if they are congruent based on that angle side angle congruency. First of all, we're given 2 angles that measure 34 degrees, so we know that they are congruent and corresponding. We're also told that 2 side lengths are the same. Both of these segments are 64 inches, so we have a pair of segments or sides that are the same. All we're missing is the angle that comes next. So we got angle side angle. Let's determine if angle L is the same as angle P. Well, here we know it's 110 degrees, so let's check and see if angle P over here is 110. Knowing 26 and 34 degrees so far, let's add those up, subtract it from 180 to figure out what's missing in that triangle. And we determine that it's 120 degrees that's missing, so that's not the same as angle L. So because we don't have 2 pairs of corresponding congruent angles, we don't have angle side angle congruency. So no, the triangles are not congruent, or there isn't two pairs of congruent angles, and we do not complete the congruency statement. Please don't complete the congruency statement if the two triangles are not congruent. All right, next up, we're going to start completing a two-column proof. This will be the first time we've done this, so I haven't made it completely blank. I've only given you partial blanks here, and I've given you a word bank over here to try and use. Whenever we do a two-column proof, there is a few steps that help us to complete it. The first step is always to write your givens. Start with those. So notice that the given here, angle A congruent to angle C. In proofs, you're always given some statements in a given section, so start with those that are given. And your reason, don't complicate it, is because it was given to us. So we can cross off that given. We've used that up. We've got 4 more choices to work with here. When you have written your given statement, ask yourself for step 2, does that allow you to draw anything that's congruent in the diagram? So use your congruency marks and mark up your diagram. Well, we know that if angle A is congruent to angle C, then we can use those little arcs or rainbows there and symbolize that in the diagram. So now that we've drawn what we stated, or stated what we drew would be the third step, but we don't need that yet. And we're just going to repeat the process. So we'll go back to our givens, if there's any givens left. We have one more here. E is the midpoint of segment AC, so we'll put that in the next box. Cross it off our list over here. And notice that the reason was because it was given to us. Then ask yourself, is that statement allowing you to draw something or mark your diagram in some way? Well, yeah, of course. If E is a midpoint, E can only be in the middle of a segment if on either side of that midpoint we have equal parts. So that must mean that the distance from A to E is the same as the distance from C to E, otherwise E would not be in the middle. So we now know that these two segments are congruent. We can put segment congruency markings, little hash marks there to symbolize that. And so that's where this third step comes in. Sometimes we draw things that we haven't stated yet, so make sure you state what you drew. So let's state that segment AE is congruent to CE. So that was one of our choices here. We'll fill in that blank there. All right, here's the tough part. Sometimes the reasons are tough to come up with, but sometimes you can get clues from statements directly above. So in the statement directly above, we were told that we had a midpoint, and that's why we said that these two segments were congruent. So our reason for saying that is because of the definition of a midpoint. We know that if E is in the middle, we must have two segments that are equal on either side there. All right, so now we've used up our given statements. And so we come to our fourth step. The fourth step I like to call our plan. Usually if we use up our given statements, we've got 2 out of 3 pieces of our proof. We're trying to get angle, side, angle. We have angle and side, but we're missing another angle. So you know that the angle that comes next in order is going to be the one that we need. So what do we know about these 2 angles? Why are they congruent? Well, we know that they're vertical angles. So we can say that they're congruent. Make sure that you don't just say angle E, that's not specific enough. We got to say AEB is congruent to angle CED. That was already done for us. And the reason we know that they're congruent is because we know that vertical angles are congruent. So that's our reason. You can say the definition of vertical angles, or you can say what is the definition. Vertical angles are congruent. And then lastly, if we've gotten to our last spot, the last thing to do for step 5 is rewrite the prove statement. We were asked to prove that these 2 triangles are congruent, so that's always our last statement, is to rewrite the prove statement. And then we know that we proved that the 2 triangles were congruent because we used that angle side angle congruence. All right, let's see in the next example if we can follow that recipe and complete all of the blanks in this next one. Feel free to pause the video and try it on your own, see if you reach a stuck point at all. Then you can unpause it and I'll walk you through it. All right, we're going to start with our given statements. So I'm going to start with angle S is congruent. Sorry, angle S and angle U are right angles. Don't change the statement. Rewrite it as it is. Our reason is always because it was given to us. Does that allow us to draw something in our diagram? Well, sure. We can mark up angle S and U and give them their right angle symbols, those boxes. Now that we know that they're both right angles, we know that they're congruent. So let's make sure that we state what we drew. We said that they were both right angles. Let's say that they're congruent because right angles are congruent, or the definition of right angles, or right angles equal 90 degrees. Lots of different ways that you can say it as long as you describe why you said that angle S is the same as angle U. So we've used up that given statement. We're going to move on to the next given statement. Segment RV bisects segment SU. Bisector means that it cuts something exactly into two equal parts. So if we're bisecting segment SU, that must mean that ST and UT are congruent. So let's give them segment congruency markings. We haven't said what we just drew, so let's make sure and say that segment ST is congruent to segment UT. Oops, I don't know why I don't have a segment symbol there. That should be there. And then the reason why is because we bisected it. So that's the definition of a bisector. So again, getting a little clue for a reason by looking back one statement. All right, now we're to our plan. We've used up our given statements. Let's see what pieces we have and what piece we need next. We have angle pieces and we have side pieces, so we must need the next angle in order there. So we must need to talk about these two angles. Hopefully you recognize that they're another vertical pair there. Let's say that they're congruent. Let's draw it. And then let's state what we drew. Be careful, we can't just say angle T. We're going to say angle STR and angle UTV. We know they're congruent because that's the definition of vertical angles, or we can say the definition, which is vertical angles are congruent. We've now completed our proof. We have angle, side, angle, congruency. Let's just name these two congruent triangles such that in the name, corresponding parts are in order. So we could do this three different ways. This is just one way to do it. If I name the first triangle RST, I gotta name the second triangle VUT because R and V correspond, S and U correspond, and T corresponds with itself. And again, the reason was angle, side, angle. So there's an introduction to writing two-column proofs just using angle, side, angle. We'll use some other methods in the future. It'll get a little trickier when we know more methods, but the process will always be the same. We'll always go through this 5-step process to do it. So good luck identifying that first type of congruence, angle, side, angle, and practicing some proofs using it.